All right, so last example from the notes. Sorry to cut off the last video. We're gonna do this example, okay? So this example is from that community college from the last set of notes, and it is finding, sorry, I did it yesterday. I already forgot what we did. So the possible combinations of X and Y. So I think it's the one about how many credits they have, right? So at the first campus, the probability of a student taking 12 credits is 0.25. And then the second campus, when they ran the study, it was the same thing. The probability of a student taking 12 credits is 0.3, right? So if you're trying to find the total, the probability of a student taking 24 credits at both campuses is going to be 0.075, right? And how did they get that, right? So that's where you had to multiply. So the probability of X times the probability of Y. So this is 0.25 times 0.3. That's how they got that. Here it's 0.25 times 0.4, and they got 0.10. Okay. So this is the same stuff from this table, just kind of organized more neatly, taking this column here. So less numbers. Yeah, I think it's just organized in order. Okay. In numerical order from 24 to 36. And these two formulas are from the first set of notes, right? So how do you find mu of X? Well, you have to sum the actual event times the probability of that event for all of them, right? So to find the mean of this new data set, I'm going to have to do 24 times 0.75 plus 25 times 0.03 plus 26 times 0.015, which is what you can see I've done here, right? So this one. So I started writing that out. So the mean or the expected value of this sum of certain number of credit hours on both campuses is found here. And when you do that, you get 29.65. Okay, then it's asking you to find sigma squared. So sigma squared is the variance. So what is the variance of this new set here, which is the sum of credit hours? So when you are, I'm going to read this first. You cannot directly find standard deviation from two combined sets. It has something to do with the mathematical calculations of errors. So if you think of it, if I know the standard deviation of this one thing, right, there's an error of plus or minus 2, and then this other event is plus or minus 4. I can't like necessarily combine them because it's not going to be plus or minus 6, right? You can't combine them that way. There's a little bit more math behind it. I tried to research the why. Something to do with the central limit theorem, sorry, from calc. And because of that, the only thing you can actually compare is the variance, which is the standard deviation squared. And so the variance formula from our first set of notes is up here, right? Again, you have to sum all of the differences between your X and the mean and square that and then multiply it by the probability. So I've done that here. I started it, right? So for the first one, it's going to be 24 minus, what's the mean? 29.65. I square that and then multiply it by the probability of 0.075. I would do that for each line, and it comes out to be 9.63. Okay, that's very tedious, so I want to show you how you would do that on your calculator. So let's go to this. Okay, so I already went through and put all of the data points in this list, right? So I named this one S and I named this one P of X. So if I want to find my new mean expected value and my new variance of the sum of the combination of those two different campuses, I'm going to go to menu. Then you go to stats, stat calculations. We want one variable statistics. So this is fine. My X list is going to be S. My frequency list, my Y list, how often that occurs is going to be P of X, right? All of this other stuff is fine. So I hit OK. And you can see here is that mu sub S 29.65 that we got from doing the manual calculations. And the variance is down here. Okay. The variance is 9.628. So that's the quick way to do it if you don't want to do all the calculations. I would do this all the time, right? Because you're likely to make an error when you have to do it by hand. So let's switch back to our notes. Okay. So I filled this in for you for any two independent random variables, X and Y. If the total is X plus Y, you can find the variance by summing the two standard deviations after you square them, right? So sigma x squared plus sigma y squared. So in general, the variance of the sum of several independent random variables is the sum of their variances. Okay, you can't sum the standard deviations, only the variances. So, oh, here's a note. On the AP exams, many students lose credit when combining two or more random variables because they add the standard deviations instead of adding the variances. So don't forget that. Last example, I think. Just kidding. There's more. Let B equal the amount spent on books in the fall semester for a randomly selected full-time student at this community college. So the mu of B is 153 and the standard deviation is 32. And then back in the first video, we said C is the overall cost of tuition and fees for a randomly selected student, and this was the mean and the sigma of that. So now it says find the mean and standard deviation of the cost of tuition plus books. So C plus B for a randomly selected full-time student. So we know that if I need to find mu of C plus B, it would be, I'm going to type because it's a little bit easier to read. That's C plus B. It's just going to be adding the two mu's, right? So it's 153 plus what's the other one? 832.50, which equals 985.50, which makes sense, right? If I'm trying to find the cost of my tuition in books, I can take the average cost of books, take the average cost of tuition and add them, okay? But what if I'm trying to find, one second, let me pause. Right, so someone walked in, sorry, pause the video. Okay, let's keep going here. So then if I need to, let's see, find the mean and standard deviation. So we can't find the standard deviation, but we can find the variance, right? So sigma squared of C plus B is going to be the sigma of C plus the sigma of B both squared. But then I'm stopping to think because it says it has to be independent random variables. So is the cost of tuition separate from the cost of books? Well, no, they're related. Generally, the more credits you take, that means you're taking more classes, which means it's going to impact how many books you're buying. So in this case, we actually, this cannot be determined because events are not independent. Okay, so I'd stop and think for a second. I almost just calculated it. All right, check your understanding. Those solutions we posted, so you can pause the video and try that. So now what happens if you want to subtract? You want to find the difference. So if you want to find the expected value of the difference between two events, X and Y, just what you would think. It's just like the one from before. Instead of adding them, you can subtract them. So this will be M of X, not M, mu of X minus mu of Y, right? So that makes sense. If I want to know the difference, if I think of that example, I sell this many sweatshirts per week, and then on average, I sell this many sweatpants per week. What's the difference? Well, I can subtract them, right? But you cannot subtract variance. And if you think about it, variance and standard deviation is telling you about the error. So if I know the error of one event and I know the error of another event, but combining them, you're never going to decrease the error, right? The error is either going to be some number near those, right? Or some combination of those. It's not going to go down. So you cannot subtract them. So it says for any two independent variables, X and Y, if D equals, oh, this is supposed to be X minus Y. So change that to minus, okay? Then the variance of D is, you still have to add them, okay? Because you're combining two events, the error or the variance with those two events gets combined. So don't subtract them. So let's actually put this in play. So you can try this one, okay? Maybe you want to try it after we do this example. So let's do number 3. Number 3 says, suppose that a certain variety of apples have weights that are approximately normally distributed. There's that word again. with a mean of 9 ounces and a standard deviation of 1.5 ounces. If bags of apples are filled randomly, selecting 12 apples at a time, what is the probability that the sum of the weights of the 12 apples is less than 100 ounces? So we need to figure out a plan. So this is like the same setup that from our normal distribution unit. So we are finding what is the probability that a random sample of 12 apples has a total weight less than 100 ounces. That's our question. So what are we going to do? We're going to say X equal the weight of, or we knew one, yeah, a randomly selected apple, right? And we know it's normal. The mean is 9 and the sigma is 1.5, right? Okay, so in our notation, we could say X sub 1 is the first selected apple. I can't write X sub 2 right now, but X sub 2 would be the second selected apple, right? So forth. Apple, dot, 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 dot. Okay, so if we're talking about the total of 12 apples, then we're going to say the total equals X1 plus X2 plus X3, right, all the way to 12. Dot, 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 dot. Okay, so now let's do it. So T is the sum of 12 independent random variables, right? Selecting each apple is random. So we are summing 12 independent random events. So, and we also know it's normally distributed, so we can use our sum formula for the means, which we just talked about at the start of the video, right here, right? Or the end of the last video, actually. So we're going to add them. So I can think, let me write this, mu sub T equals, now I'm going to type, right? And I could say it's going to be the mean times of X1. Well, the mean of the first apple is 9, right? The mean of the second apple is 9. The mean of the third apple is 9, right? So the fast way would be to just do 9 times 12, which is going to be 108. Is this ounces? Yes, ounces. So we would expect the mu, or the expected value of 12 different apples. We expect it to weigh 108 ounces. Okay. Now we also need to, for normal distribution, to find the probability, we need standard deviation, right? But we need standard deviation of the 12 apples. So, but we can't do standard deviation. We have to do variance. So we're going to do sigma squared of the total equals, and now we're going to use this formula we talked about before. We're going to add them all up, right? And they have to be squared. So it's going to be 1.5 squared plus 1.5 squared, right? And I have to do this 12 times. So dot, 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 dot. You end up with this equaling 27. I think it's 27. 1.5 squared times 12. Let me check here. 1.5 squared times 12, 27. So our standard deviation of the total is 27. Okay, not our standard deviation, said the wrong word, our variance. So you'll notice the variance is just standard deviation squared. So if I want the standard deviation, I can unsquare it, right? I can take the square root of 27, which ends up being, what does it end up being? 5.2 ounces. So we expect 12 apples to weigh 108 ounces with a standard deviation of 5.2 ounces. So now we have everything we need for our calculator. So let's switch to that one. Right. Let's go to the calculate part. All right, so we're going to hit menu, stats, nope, probability, right? And then we want normal distribution. We want normal CDF. So I'm going to go back and draw a picture, but what we want is less than 100 ounces. So we want negative infinity to 100. Our mu is 108 and our sigma is 5.2. So if I put that in there, we get 0.2 Did I do something wrong? 0.293, negative infinity to 100. 108. Oh, I see a mistake. I typed 15.2 instead of 5.2. So let's do that again. I was like, my answer is not matching. Distribution normal. Oh, I did the wrong one. Maybe I can just switch in here. Oh yeah, I can just delete that 5. Will it let me? There we go. All right, so the answer is 0.062. So let's switch back. So I would say our conclusion is there is about a 6.2% chance that the 12 randomly selected apples will have a total weight less than 100 ounces. Okay. But if this was an FRQ, the thing I've forgotten, which I'm going to go back and draw, is that I can draw my normal distribution, right? And then I can say, I know this is 108. I know this, I would put standard deviation underneath here. And what am I looking for? I'm looking for the area under 100, right? So this area. The other way you can type it is you can put norm CDF and you can put negative infinity to 100 and then you put 108 comma 5.2. You can do that, but just remember you need to label, like each part needs to be labeled. What is this? What is that? You can draw arrows or you can just list it underneath it. What is 5.2? All right. Okay. So that is kind of putting what we just learned back with normal distributions. Another check your understanding where you're going to run through all of the 4 steps. So try that and check the solution. And we're done. Okay. So this will be the next lesson. All right. See you guys later.